this is our shearing stress, and the shearing stress, I want you to have a good habit to draw that the shearing stress is generate clockwise rotation of the element, anti-clockwise rotation of the element. So I'll put down here rotation. What this means is the rotation of the element. Okay. So we know that stress X is greater than stress Y. So over here, this is our stress X line. Okay, so this is our stress X line, and then another line over here. This is our stress Y line. Okay. So for the fact that the shearing stress, there's no shear over here, the shear stress is equal to 0. So this is where your point X is. And this is where your point Y is, because the shear stress is 0. So from here, you will know where your stress average, like what I showed you before, right? So the center of circle is your stress average. So this is equal to stress X plus by stress Y divided by 2. You don't need to remember the formula. You just know that you want to find the stress average. Okay, so the center of the circle is over here. Right, so this is the center of the circle. So from here to here, so the average stress is from 0 line. Yeah. Okay. So this is your stress average, and then you can now construct, knowing where the center of the circle is. You can use your compass. Okay, you can draw a center. You can draw a circle. Okay. Right. So this is your Mohr circle. Anything else? Okay. So the next thing that I'm going to introduce to you is, for this case, this will be your stress. This over here, where I'm going to draw now. Right. Right. So this height over here is max, and you realize your the radius of the circle. Okay, the radius of circle is known as our tau max. Okay, and then I'm going to introduce, since we are here already, and I'm going to introduce you 2 points over here. So this point over here, I call my stress 1 point, and this point over here is our stress 2 point. Does not matter which one I call 1 and 2. I can flip this over. Okay, does not matter at all. If you want to call stress 1 on the left hand side, nothing is wrong with that. So we work the stress 1 and 2 are the principal stresses, where we realize that the shear stress is equal to what? 0. Okay. Right. So this is quite a comprehensive introduction to Mohr circle. Okay, telling you how to calculate your stress average, tau max, things like that. Then I want to do another situation for you guys, is where again we have another element. Right, we have an element down here, and now one set of arrow is still the same. So point X. So this is positive, and this is what? In tensile. Now, if the arrow point towards the surface, right, into the surface like this side, what we call this is stress Y. And when it's acting towards the element surface, we call it negative. Okay, negative means it's under what? Compression. Okay. So now if we were to draw a Mohr circle, okay, so I think I'm going to bring it down slightly so I have more space. Right. So I will still call this our point X. And over here, this is our point Y. Okay, then we draw our Mohr circle again. Oh, sorry. Undo. So we draw a Mohr circle again. So okay, so that is our normal stress, and then this is our shearing stress. Element rotate clockwise, element rotate anti-clockwise. Okay, then we are going to call this point our stress X line. Yeah, I try to, okay, so this is our stress X line. Okay, and then the next one over here, this will be our stress Y line. Right, so because they have no shear, right, so this will be our point X. Over here, this is our point Y. Then we can construct our Mohr circle. All right, and then from there, so 5. So we know that over here, this is our stress average. No, wrong color. Okay, so the stress average, usually we call this 0.0. Okay, so now the distance from here to here, oh, hold on, the distance from here to here, this is known as our stress average now. Okay, so one thing I want you all to take note is on the element, right, on the element, right, the angle between point X and Y, okay, from point naught, right, so this angle over here to here, right, is 180 degrees, right, is 180 degrees, right. So if you go back to the element, the angle between point X to point Y, this angle over here is what? 90 degrees. Okay. So a key element to observe is element. Sorry, why am I in Mohr circle? Sorry, okay, in Mohr circle, the angle between X and Y form O is 90. So in element domain, right, this angle is 90 degrees. So i.e. in Mohr circle, if we call this 2 theta, on the element is what? Theta. And the element is the real world, yeah? Right? So the element is physically what the stress state on the shaft or on the structure. That's the real world. Okay, bring it back to the real world. So that's what I want you to observe. So on Mohr circle, X, the angle between point X and point Y is 180. On the element X and Y, this angle is what? 90 degrees. Okay, so I want you to really observe that. Okay, so maybe I give one more short example regarding normal stresses. So if we have a state now, another element. Okay. Now we have the element over here. Then this element over here only have a stress state like this, just like this. So what this means is stress X is negative, and in compression mode, right? Stress X, when you don't see an arrow, is equal to what? 0. Okay, when you don't see an arrow means it's a 0. Okay, don't make things up. Okay, don't make things up. Then you have, okay, so this is your this is your transformation. This is your normal stress, right? And then this is your shearing stress, right? Element rotate clockwise, element rotate anti-clockwise, and we know that this line is our stress X line, right? And then we have another line over here, compressive. So this is your stress Y. Then from here, we can identify that this is our point X, right? And over here, this is our point Y. Okay, then we can do a circle, right? And now what you realize is our stress average is in compression now. Okay, so the distance from here to here is your stress average. Okay, so anything on the right hand side, right, in terms of normal stress is in tensile. Anything that is on the left hand side is under what? Compression. Okay, so that's for your normal stresses. Okay, so the next thing that we are going to look at is shearing stress. Okay, so the next thing we're going to look at is shearing stress. So if I go, anyone, any questions so far? Anyone putting hand so far? No, I don't see it. So the next thing that we'll look at is shearing stress. Yeah, no one is asking question. Okay. So the next thing that we're going to look at is shearing stress. Okay. So shearing stress is a bit more not complicated, but a bit more things to remember. Okay. Or it can be confusing. Okay, it can be. So shearing stress are stresses. They are running parallel to the surface. Okay, let me highlight what I mean. So you have X and you have Y, and then you have your element down here. Okay. Okay, so this is your element. So I'm going to draw the axis inside. Okay. So this is your x, your y-axis. Okay, so this is your x.